Okay, guys, we are 22 and we can start. Okay, so second, just let me organize my screen. Okay. Okay, that's good. So guys, and we start with exercise number 1 from the DD session number 6. So, and here you ask to compute the mean, standard deviation, and the variance or dispersion. It's how it's called differently. And I think that we did it many times before, and I hope that for you it was a very easy exercise and no questions here. So just let me recap the procedure, the algorithm, how we compute the mean, how we compute standard deviation. Yeah, and so we do it briefly. So which is the formula? So which is the main formula you have always bear in mind. You have to always bear in mind. So that we calculate when we have a random variable, when we have the probabilities of its values. So it's just a sum over over the product of values multiplied by its probabilities. So here we just multiply row by row, and we sum it up, and we get that expectation of our random variable is equal to 6. So, yes, sorry, just I see the question, and yeah. Good. About this exam, frankly, guys, I think you have to direct all your questions regarding the exam to Anna, because he is a lecturer, and actually I don't know, I'm not the person who is in charge for your examination, and I mean, yeah, frankly, I don't know any special information, anything regarding how it will be organized, etc. So I know that unfortunately it will be organized online, maybe unfortunately, maybe fortunately, I don't know. So it will be open book exam for sure, and yeah, and that's it, because actually I cannot add more. Yeah, actually yes, because and also I didn't see exercise which will be in the final examination. So, but no worries, no worries. I think if you comprehend the lecture material, if you comprehend the seminar material, so it will be more than enough. And yeah, and also don't forget about your homework, which is homework from the TT session number 5. So also don't forget to do it, to complete it, because I think it's 20% of your final grade, so it's quite important. So, but yeah, guys, I think if you have some special questions, it's better to ask Anna. Yeah, because she is in charge for it. Yeah, okay. So I think we can continue. Let's see. Yeah, so the next step we have to compute the dispersion. So which is again, so we use the information we got on the previous step about the means we calculated. So you also have to learn by heart this formula. So which is just a weighted sum of quadratic variations of each value of our random variable. Yeah, and this is how we do it. So we just subtract it from each observation the mean, and we raise it to the power of 2 and multiply it by its probability. So, and we sum it up, and we get that the variance, the dispersion, is equal to 4.5. So again, just use the formula you learned during the lecture, and that's it. So nothing special. I hope that every everybody here understands how to calculate mean, variance, and standard deviation, because it's like really basic, and with this stuff you have to do like really fast and very without any trouble. So and yeah, sorry, C. The point C, so you just take the square root of your variance and you get the standard deviation. So, and also here I just want to recap that by itself the variance is not interpretable. So because it's expressed in not in the same quantities as the original random variable, and in opposite the standard deviation is expressed in the same quantities as the original random variable. So bear it in mind and don't forget it. And here it's just as a measure of scatterness of our original random variable. So this is it. So it's just some meaningful interpretation of what we calculate, just to give you a sense of what we are doing right now. So, okay, good. And yeah, so I think we can move to the next exercise. This is the exercise about marital counseling center in US. And they are looking for the probabilities of new clients for the next year. So, and in this case, the random variable, which is the number of new clients for marriage counseling for the next year. It's given in the first column, and the probabilities of coming with new clients is given in the second column. So, and what you ask for? So you have to detect whether which probability is valid or not. So I think we also did it many times in the previous session. And also you have to find the probability of a particular number of new clients for the next year. So let's just do it. I think the first two exercises, this is just a recapitulation of what we did before. Yeah, so as you remember, so in order to justify that our probability distribution is valid, so you have to justify that two conditions are satisfied, so that all probabilities lie within the interval from 0 to 1, and that the sum of all probabilities is equal to 1. So, and as you see from the table, like both conditions are satisfied, and yes, we can conclude that it's a valid probability distribution. So, yeah, so just bear in mind these formulas. Yeah, and so we have to calculate what's the probability that marital counseling center will get more than 13 new clients. Again, you work with a table. So you work with a table. So let me redraw with table here just for your convenience. I will do it one time. So the probability function is, yeah, so 10, 20, 30, 40, 50, etc. So and the probability that more than 30 new clients will come, which is the probability which starts from here. So and here we have sorry, not from here. Yeah, that's my mistake. From here, of course. Okay. Yeah, from here. So and the probability of 40 new clients will come is 20%. The probability that 50 new clients will come 35%, and 20% that for 60 clients. So and we just sum it up and we get as a final result that 75% that more than 30 new clients will come. So I think also no questions here. Again, a similar question about what's the probability that more than 20 clients will come. So we just add to the previous number to the 75% new 10%. So it's the probability that 30 new clients will come. And again, yeah. So I think everything is clear. Yeah. So we did it many times, so I will not touch here for long. Yeah, again, so in the point you ask to calculate the variance, the expected value, the variance, the expected value versus the mean of our random variable, and as you remember, you have to sum up the product of each observation of our random variable multiplied by each probability. And you sum it up, you get that the mean of your random variable is equal to 43. So 43 new clients is expected to be seen by marital counseling center in Virginia. So this is it. So this is interpretation of this mean. Yeah. So afterward we are calculating for the variance first. Again, as I said, this is the weighted sum of. Excuse me. Yeah. I think you have. So I think you speak not to me. Yeah, just let me see how I can switch off your mic. Yes, yeah. Okay. Yeah, sometimes it happens. Yeah. So now we can continue. So we muted with member. We muted with participant. So again, yeah. With this weighted sum of quadratic variation for each observation. So we calculate the variance using this formula. So we calculate the standard deviation by taking the square root of our variance, and it's equal to 14.17. So I think everything is clear. Yes, and which is it? So it was the exercise number 2. Which was the exercise number 2, and I think we can move to the next exercise. Yeah, and here, yes, the exercise number 3, which is more serious task, and I think you have to pay real attention to with and the next exercise where you have to compute the probabilities for the random variables, which is uniformly distributed and normally distributed. I think you will use it a lot during your bachelor, and if you will go to the master level again. So it's very important and useful content. And I hope just be sure for yourself that you really understand what we are doing. So, and here, yes, I think I have to recap a bit what the continuous uniform probability distribution is. So yeah, before we start, so all the time you have to start with the formula, and the formula for our uniform distribution is equal to the next expression. Yeah, which is 1 over b minus a. Where x is lies between a and b, and a, which is the smallest number of our supporting values, and b, which is the largest possible value our random variable can take, and which is 0 elsewhere. Yeah, so, and as you see, which is a constant over the range of all possible values. Yeah, and which is just a straight line. And yeah, so also some facts about uniform distribution. Also, please remember that the probability of uniformly distributed random variable is equal a plus b divided by 2. So which is just a middle of with interval where with random variable lies and the variance if you don't need it. So I challenge it, but well, maybe you so with b minus a in square divided by 2. So we start to have to remember for uniform distribution. So and here the first task you are asked to show the graph of with probability distribution. So let's just do it. So which is a graph? As I showed you, which is a function, which is a straight line over all possible values our random variable can take. And also, I would advise you to check if you draw the correct distribution. So please remember that the valid distribution, the area under the curve of any valid distribution is equal to 1. So, and here you can check by calculating the area of this rectangle. And I think if you remember from the school, the area of the rectangle is equal to the product of width by height. So and here the height is 2, and the width of our rectangle is 0.5. So and we multiply it, and we see that indeed the area under the curve of normally distributed variable is equal to 1. So then we did everything right. So we did not make any mistakes. And yes, so this is the way how we do it. Also another way how to check whether it's the valid probability distribution, you calculate the integral. I don't know whether you are familiar with the integral concept. So I think you should have been given with that concept during your math class in the Bachelor. So you just can use with formula. As you remember, so you integrate by your random variable from from 1, of course, from 1 to 1.5. So I will not do with exercise right now, but you can also check that it's equal to 1. So when we integrate the probability function of our random variable over the all possible values. So this is 2 ways to check whether width distribution is valid. So, but I think especially for uniform distribution, just use the formula for rectangle. So, yeah. Sorry if I spent too much time for with explanation, but I think it's also, I just want to give you some intuition which is behind of with stuff, and I think it's always good for you to know how it can be visually expressed. And it's always beneficial for you to understand what's the intuition behind all these graphs. Yes, and the area under the curve, yes, which is a very important concept for continuous random variable probability distribution. Yeah, okay. We will talk about these more. Yeah, good question. Actually, I don't know whether you will be obliged to do the theory in the exam. Frankly, I don't know. I think that for week course, mostly you will be asked to do some practical exercise. Yes, but also I think for you, Chantal, that it's good to bear in mind that and to refresh with knowledge on the theory on with distributions or with I don't know means, how to calculate means, standard deviations, dispersions, variances, etc., etc. So how to calculate percentages. Yeah. I don't think that there will be a lot of questions regarding the theory, but you'll be ready. Be ready and be prepared with the timeline. Yeah, but I don't think that it will be the permanent part of the exam. Okay. Yes. So, and for the point B, we have to calculate the probability that the random variable takes any particular number. So, and as you remember, I quote from the lecture. So, for continuous random variable, by definition, because it's continuous, and it has infinite number of values in its support. But when we have the infinite set of possible outcomes, then the probability of one particular outcome is yeah. You see, Patrick answered the question somehow. Yeah, because actually, yes, we did not communicate with Anna regarding such questions yet. But yeah, as you see, be prepared. Okay, guys. Yeah, as I told you, yeah, so the probability that continuous random variable takes any particular value is always zero. So just for you to remember. Okay, so let's go to the next point. So, and here you have to compute the probability that our random variable lies between 1 and 1.25. So, and here, as I told you, so you have to calculate the area under the curve of our probability distribution, and with red rectangle, and the area of this rectangle is equal to 2 multiplying by 1.25, and it's equal to 0.5. So since uniform distribution is very easy distribution, it's a very simple distribution, and you can easily calculate with areas under the curve by yourself. For example, going a bit ahead. So for normal distribution, of course, it will not be so easy. That's why we will use some special tables. Okay. But for uniform distribution, just do it on your own. I don't think that it will be a problem. So again, here the same task, but for another interval. So here for the interval for whether the x lies within 1.2 and 1.5. So you just calculate the area of with the yellow rectangle, and with area is equal to 60% to 1.6. So that means that the probability that with random variable lies within with interval is equal to 60%. Okay, good. Guys, any questions regarding uniform distribution of continuous random variables? So I think it's pretty straightforward, and I think you just have to remember that this probability is equal to the area under the curve of the probability distribution. Yeah. Okay, this is it. Perfect. Yeah. So, and here the next question. Here we deal with the standard normal random variable, and we have to compute the following probability. And also, I think I have to recapitulate what does it mean, the standard normal random variable. So you can standardize, so you can standardize any continuous random variable which is ruled by normal law into you can translate it into the standard normal random variable, and you do it by doing the following. So you subtract the mean of your random variable, and you divide it by the standard deviation. And that's why it's called the standard normal random variable, because it's already standardized. And for the standard normal, for the standard normal, so I have to remind you that the mean is equal to 0, and the standard deviation is equal to 1. So, and again, the normal distribution, which is a bell-shaped distribution, where the mean, mode, and median lies at the same point, and which is the highest value of with probability function. So with is symmetric, it means that the area under the curve to the left and to the right from the mean is equal. So this is the meaning of symmetricity in this case. And what else? The total area under the curve is equal to 1, so it means that for normally distributed random variable, the area under each tail is equal to 0.5. And then the sum is equal to 1. So I think with all features, all characteristics, you have to remember about the normal distribution. So, and also, which is very important distribution, because the people from many branches of science believe that world is ruled by the normal distribution, by the normal law. So, and you will use it a lot during your further studies, especially during econometrics, so especially in the beginning. Yeah, and during hypothesis testing, I think we will not cover hypothesis testing in this course, but further on, I think for sure you will do it, and to understand the normal distribution is extremely important for your future studies. So guys, also be sure that you understand what we are doing here, because I think it will be very beneficial for you in the future. So with this the brief concept, of what we are doing here. Okay, so here we have to calculate with probability. So let's start. So let's do it. So as I told you, when we calculated with probabilities for uniform distribution, since with function is not so trivial as for uniform distribution. So and it's sometimes it's not very easy to calculate these areas. So that's why we resort to using the tables for with distribution. And here, for example, I used one-tailed standard normal distribution table. Yeah, and please bear in mind, when we use one-tailed, it means that with number indicates the area under the curve between the mean and your quantile. And the quantile in this case is equal to 1.83. 83, yeah. So be sure if you have two-tailed standard normal curve table, so it means that that with the resulting number is given for the interval from the minus infinity to your quantile. Yeah. So, but I think I will show you. I will show you next. I will show you further how to use two-tailed. Okay. So far, so just pay attention. Pay attention that it's one tail, and one tail. That means we calculate the area. So the area under the curve for the interval between 0 and our quantile. So yeah, so you can ask me how to use the table. So as you see here in the row, you see the tens of our quantile, and in columns we see the hundreds of our quantile. Since our quantile is equal to 0.83, so we have to decompose it into tens. So it's 1.8 plus 100. It's 0.03. And the area under the curve for which quantile is equal to with number. So, and directly from the table we get the answer. So I'm sure that this is very trivial operation, but still you really have to remember that here in rows tens are given and in columns hundreds are given. So and which is the way how we use it. Okay, yeah, and it means that the probability that our standard normal continuous random variable lies between 0 and 0.83 is equal to 30% approximately. So which is good. Okay. Guys, please don't hesitate to ask me any questions you have now, because it's extremely important for you to understand how to use this table. I think in exam for 100%, not for 100%, okay, but for 99% that you will get the task for doing the similar stuff. So be sure that you understand how to use this table. Okay. Here you have to calculate, the following probability, and here we have to use the feature of our normal distribution that is symmetric. So the normal distribution is symmetric. That's why with areas which is colored in gray, they're equal. And for example, if we have only one tail, the table, which is usually only for positive numbers, so we just have to flip upside down with negative number, and calculate it for the probability that our random variable lies within the interval from 0 to 1.57. And again, so you have to decompose your quantile, your upper limit into two parts, into integer plus 10, which is equal 1.5 plus 100, which is equal to 0.07. And again, you are looking for the intersection of with row and with column, and you find the answer. So the probability that the random variable lies between minus 1.57 and 0 is equal to 45%. So this is it. And yeah, for sure. Also, in the exam, you will be given with tables. I think so. Or will be given, or you will, for sure you will be provided. So no worries. With tables, which is just default stuff. So for sure you will get access to this. Okay. Okay. It goes well so far. Okay. Yeah, and here we have to calculate the probability. Please attention that, yeah, also pay attention to with inequality signs. That we have to calculate that is more than 0.44. So it means we have to calculate what is the area under the curve in this tail, which is covered by pink. Yeah. And here we have to use the feature of the normal distribution, that the area under the total area under the curve is equal to 1. And this means that the area in this white colored part is equal to the probability that our random variable lies to the left from this quantile. And again, so this is the first step you have to do. And next you have to use your table. So since it's symmetric, as I told you, so the area in this left tail from the mean is equal to 0.5. And now we just have to find the area under the curve from 0 to our quantile, and we do it again as we did it before. So we decompose it in tens and hundreds. So we are looking for the intersection, which is equal 70%. So we sum it up, we sum these two probabilities up, and we subtract it from the 1. And yeah, it's 67, and when we subtract it from 1, it's 33%. So, and this means that the probability that our random variable lies in this tail is equal to 33%. So with the feedback. So, and it was the second and the final step. Yeah. So as you see, you just have to understand what's the meaning of the normal probability, and you have to use the features and characteristics of these probabilities to calculate it. And of course, you all the time use the table. Of course, you can do it. You can calculate with probabilities on your own by taking the integral of the function of the normal distribution. So let me just also briefly recap what the function of this. So it's a bit cumbersome. Yeah, but still I think you have to also, it would be beneficial for you if you remember this. Yeah. So and as you see, like two parameters determine the shape and the shape of this distribution, which is the standard deviation and the mean. And here, just let me use another color. Sorry. Okay. Yeah, and you see, that's why these two characteristics of our random variables is extremely important because most of probability distributions besides of uniform or normal distributions are defined, their shape is defined by these two measures, by standard deviation and by, yeah. And actually, the way how with probabilities are calculated in these tables. So I don't know if you're interested in that. So that's just for those people who are interested in. So we just calculate again the integral with probability function over x, and for one tail, so we take the lower limit, the lower limit as 0, and we take the upper limit as our compile. So in our case, it's so this is just an integration. And so if you do it algebraically correctly, properly, so you will get that it's equal to 0.7. So if I just give you the broad picture, you understand, guys? So just the broad picture for you just to understand what's really going on here. So this is not a magic, it's just calculation for this integral. And and since for normal distribution, this function is quite simple and it can be easily analytically calculated for other distributions. For example, with analytical solution cannot be derived, and people use just some approximation method. That's just to give you the broad picture to understand how weird values are calculated. So no magic, just science, really. Just taking into account over wisdom. Okay, guys. So I think we can move to the next point again. So we asked to calculate that our random variable lies in the interval below 1.2. Again, as I explained you in the previous class, so again, we subdivide this area under the curve into two parts, since we have one tail of the distribution. So it's also remember to understand with which kind of table we getting with. Yeah, so we subdivide it into two parts. So we found with area under the curve, and we found with area under the curve, which is equal to 0.5, if you remember. And with area under the curve, you find from the table. You find from this intersection. Yeah, and you just sum it up, and you get the final answer that this probability is equal to 88%. Okay, this is it, guys. Yeah. So, any questions? So, because yes, I will be waiting here for 1 minute, because if you understand how we solve with exercise, I think you comprehend the material. You comprehend the material very well. So I just give you 1 minute to breath, and we will move to the next exercise. Yeah, and meanwhile I will drink water. Okay. Okay, guys. Since you don't have any questions, so that's good. I'm really proud of you, and I'm really happy that you comprehend it, that you understand everything, what's going on. Okay, then let's just move to the real world application of this stuff. So here you work with large cap, domestic stock funds, and you have some statistics. So first, before solving any exercise, so you have to really understand what you are asked to do and what information you have. So here you are given with average return first. Also, the next important piece of with description that returns are normally distributed. And also we have the information on standard deviation. So just immediately jot it down so that the mean is equal to weight, standard deviation is equal to weight, and that our random variable in this case this is the return of our fund is normally listed. And as you remember, it's determined by two characteristics, by the mean and by standard deviation. So with three important pieces of with exercise. So if you understand with, if you get with, so I think with is the help of with exercise. So it means that with is 50% that we solved. So okay, and you're asked to find what's the probability that individual large cap domestic stock fund had a 3-year return of at least 20%. So you can just discard all with wordy questions and you just understand. So the main questions you are asked for. So what's the probability that return in our case is at least 20%. So it means that what's the probability that our X is more or equal to 20%. So which is the first question. So also, guys, be sure that you can easily reformulate questions in words of math logic. So because in terms of math logic and then in terms of math notation, mathematical notation. So which is the first question. So the second question, what's the probability that return is 10% or less? So in this case, which is what's the probability that our random variable less than 10%. So you see, if you do with on the preliminary stage before solving with exercise, so believe me, trust me that you do really like 50%. So because afterward you just can easily start and you understand the questions and you can easily start solving the questions because afterwards it goes just a technical part of the question. And it's very important to understand the meaning, the essence what you're asked to do. Yeah, okay. So with this is, and we can go to solve. We can go solve it. Okay. Again here, in the answer to this question, I also did the same. Also, please pay attention that for simplicity, I express all our variables in not in percentages but in ratios. Just for simplicity to work with tables, to find with areas under the curve. Yes. So, and which is the formulation of our question? What's the probability that our normally distributed random variable is more than 20%? So, and since also, guys, important moment, I mean, always tables are constructed for the standard normal distribution, which is which is important to bear in mind, guys. Which is for all these tables are constructed for standard normal distribution. And before using them, you have to derive, you have to you have to make your random variable to derive the standard representation of your random variable. So, and here how we do it. Actually, so first step, we subtract the mean from both sides, and you see, as you also remember from the math, it doesn't change the sign of our inequality. So you can easily do it. So you subtract the mean from both sides, and which is a pair, so which is correct. And afterwards, we subdivide this expression by the standard deviation. And again, it doesn't change the sign because this is a strictly positive number. Yes. Also, just for you to remember, that we have strictly positive. Strictly positive because this is the square root. And and the square root is always positive, as you remember from the math. Yeah, and you see, by doing with steps, we standardize our random variable. Okay, let me pick up a different color. So we standardize our random variable. So which is here, as you remember, which is a formula for standard normal random variable, and here we get it. So it means that we cannot substitute with expression with that. And for the expression on the right hand side, we just put all known information in. And which is how we move to with line. So now we can rewrite with the second line as so. Yeah, sorry, I cannot give you rewrite because somebody asked me. You can ask questions. You can ask question in the chat. Yeah. So and so this is how we move to with line. So with the probability that the standard normal variable is, so here it's not needed, sorry, it's mistake. So that the probability that our z is more or equal to with the expression. And by calculating with, we found that with the probability that z is more or equal to 1.27. So in this case, we see that the probability that our original random variable is more than 0.2 is equivalent to the probability that our standardized normal variable that is more than 1.27. Yeah, which is it. And actually, as we did in the previous exercise, so we use the feature of our normal distribution, of our standard normal distribution, and we just substitute with expression with that expression. Yeah, okay, and so I hope you remember this, and just let me redraw the graph for the standard normal distribution. Yeah. 1.27. So we are asked to find with area, and in order to do with, so we have to find we can say that we are looking for the area to the left from the mean, and for the area between the mean and our quantile. And it's just the same exercise we did before. Yeah, and since the total area is equal to 1, so we can substitute the width expression to with 1. And yeah, so and here this is 0.5, and if we use our one-tail table, you can find easily that it's equal to 39%. So, and you substitute all numbers you found to this expression, and you get that it's equal to 10%. And for example, yeah, just a second, let me show, for example, how to use other table. So, not here. Yeah, so the table. So here, guys, for example, you have a different table. So here, for example, if you are given with a table with two tails for cumulative probabilities for the standard normal distribution. Yeah, again, please guys pay attention. This is for standard normal distribution. That's why before using the table, you have to derive the standard form of your random variable. So yeah, and here, yes, so we have to find the probability that that is less than 1.27. So we go to this table. We found with quantile 1.27. Okay, this is for integer 10, and this is for 7. So, and we just looking for the intersection, and it's equal to 0.8980. So you see, so this is how we found this number, and you can easily check. You can easily check that with number from two-tailed table. From two-tailed table is equal to the result we get using one-tail table. So you see, this is a completely equivalent operation. So and we get the same result. So yeah, in that table for two-tail we found immediately 0.2 plus 39%. Yeah, so and the answer is the same. So therefore, also here the last line is also important. So which is the meaningful interpretation of what we did. So therefore, the probability that 3-year return was more than 20% is 0.2%. So which is how we calculate. Guys, I hope you understood how we did with standardization. So it's a very important line for you to understand how we first standardize our random variable, and only after which we go search for with probability. So first this is the first step in your solution. Yeah, okay. Since there are no questions, so we can move forward. Okay. Yeah. So let me switch on to the full screen regime. So, and here you ask to find that the probability of your random variable is 10% or less. Again, so this is the math representation of this question. Again, first we do with standardization. Yeah, please just bear in mind with simple formula. So we move to the standard normal variable. We calculated it, and we found that so that is mean that which is equal to the probability that z is less than minus 1. Yeah, again, so here we can use the property of the symmetric property of our normal distribution. So with the equal that the probability that it's less than minus 1 is more than 1. But here I did this operation because I used one-tailed table. Since also maybe you will be given with a two-tailed table, so you can immediately find this probability. So and let me see how to get rid of all with that. So again, so you found that you have to find the probability that your standard normal variable is less than minus 1. So just a second. Just let me see the regime. Oh my god. Yeah, sometimes it works badly. To this one. Yeah, sorry guys. So which is our table? Yeah, and we just go and look for which quantile minus 1 directly from this table. Which is minus 0, 0 tenths, and which is that is flat. So the probability is that our returns are less than 10% is equal to 15.87%. And as you can see, okay. And as you can see, so we get the same answer, but by using one-tailed table. Which is the meaning, the interpretation of the meaning. What's the meaning of this? The probability that 3 years a return, yes, return is missing, was less than 10% is equal to 15.87%. So which is it, guys? Okay. Yeah, which is it for today? Yeah, guys. Okay. If you have any questions, I think I'm sure that I will be glad to hear them. And yeah, but I think we did a good job today, and what do we need to have with us? Yes, I think Anna will provide you with all needed instructions, but yes, for sure, you will need with cumulative table, the table with that area under the curve of standard normal distribution. Yeah, yeah, for sure, you will need it. Yeah. So, guys, any other questions regarding any exercises, we covered today? We can know the probability. Yeah. Okay. But I guess you asked that if one times and Andre, about which questions you are, about which question you are asked? It's about which one when you ask to compute the probability of 5A. So it's from the previous session even. Sorry. Okay. Yeah, actually, yeah. I mean, yeah, it's just the way how we calculate it. So this is the way how we calculate it because because it's just it's just how to say the convention because we just calculate usually the right tail. So we calculate the probability that the random variable is to the left from the quantile. Yeah, so this is just because of the configuration of the table you are given. Yeah, and which is the only reason. And since it can be equivalently expressed in terms of other, in terms of inequality with the opposite sign. Yeah. Actually, we can calculate it and we do it, but just using the tables, we just need to calculate first with right tail areas under the curve. Yeah. I mean, I'm not sure whether I was clear on this question, but tell me, Andre, if it was sufficient for you, it was enough for you, or should I elaborate more with? Because actually, I mean, yeah, just how we calculate, which is the area under the curve. Yeah, just because you have tables are given in this way. Yeah, that's why you see it can be easily by using with features of our normal distribution, we can easily re-express it 0.5. You mean why the area under the left tail is equal to 0.5? Okay. Patrick, look, you have the normal distribution. And first, it's symmetric. And symmetric means that with two areas is equal. So it's just the meaning of symmetricity. And also, oh, sorry, just symmetric. Yeah, with so it just means that with areas is equal. So the areas is equal to the green area. And also since it's a valid distribution, so then the sum of all probabilities and the sum of all probabilities should be equal to 1. So it means that the total area is equal to 1. The total area under the curve of the normal distribution is equal to 1. So it means that each sum is equal to 1. And yeah, since it's equal to 1, so it means that each tail, the area under each tail is equal to 1 divided by 2, and it's 0.5. So yeah, which is it. Was it clear? Was it intuitive for you, Patrick? I mean, yeah, just you use two features of the normal distribution, that it's symmetric and the area under the curve is equal to 1, the total area. Exactly. Yes, exactly. So yes. So when we calculate, So when we calculate with area under the curve, since we have for one tail table, so we have to calculate with area curve and with area next. So we know that with area is equal to 0.5, and with area, we are searching for it from the table. So and with area is equal to 0.3849, and then and when the total area is equal to the sum, as what you see on the slide. So it's just with area is equal to 88. 0.88. Yeah. So and since with probability and since with probability that our standard normal variable is less than 1.2, which is the area under the curve with distribution, so which is the answer. So you have to understand that the area under the curve and the probability is closely connected. I would say just one-to-one. I mean, when you calculate the probabilities, by essence you calculate the area under the curve of the distribution. So which is it? Yeah. And also regarding your question, please take a look, for example, for with table. You see, for example, when for two tails. So here you don't need to do with the decomposition, because they calculate with area. For example, if it's 1.27. So you don't need to do with the decomposition, because in this table they represent the total area of with blue shaded zone. So yeah. So for example, yeah, as I told you, look, 1.27. Yeah, it's here. So we can immediately get this result. Yeah. So this is okay. So please remember, and I think in lecture, when an exercise 6.4, we didn't use the negative number in the table. 5.4. Yeah, because look, even for two-tailed table, we cannot calculate with area. So we cannot calculate with area immediately. Yeah, probability can be always positive. Yes, the area is always positive, of course. Yeah. So and And you see, so then how to explain it properly. For example, if you look at with probability, if you look at the probability that our random variable is I think she's asking about the different stuff. Yeah, so for example, if you are looking for with probability, that's for with quantile notation for with probability, and yeah, so this is not an answer. This is wrong, because look, this is not an answer to our question, because look, you are looking for with probability. You are looking for the probability that z is less or equal to 1.7 minus. Yeah. And in our case, we are looking for with probability, if I'm not mistaken, if I'm not confused. Yeah. You see, we are asked to find with area, not with one, with a strong, with a strong area. That's why we cannot even using two-tailed table, we cannot get the answer immediately. Yeah, this is it. Yes, yeah. I mean, when you calculate the area, it's always positive because it's the area. Yeah, and the probability is always positive. Maybe yes, I misunderstood your question, but if it was a question where the probability can be negative, the answer definitely no, and yeah. And yes, here please don't mix up the quantile. The quantile can be, so the support for the normal distribution, the random variable which is distributed by the normal law can take any value, positive and negative. And which is the value of our random variable, which is not probability. Probability, which is the result when we calculate the probability of our random variable, when we calculate the area. Yeah, so please don't mix it up. But yeah, the normal distribution can take any value, as positive as negative. Yeah, no matter. And I don't know whether you called during the lecture with a quantile for the normal distribution, but usually in statistics it's called like this. We call with upper and lower limits as quantiles, and actually with quantiles of our normal distribution. So also please get used to with slang, with vocabulary, but yeah, in essence, this is it. So this is everything I wanted to show you today. And we are perfectly in time. And yeah, guys, please don't hesitate if you have any further questions. So we will try to answer them right now. So if not, so I would say you have a nice day. Yeah, stay safe and healthy, and take care of your relatives and friends. Yes, and I think that with madness will continue for a long time, and yeah, unfortunately we will have exam remotely in online. So, but yeah, I hope that it will not be the issue for you, and you will pass with course without any trouble. So I wish you all the best. And we have the one remaining session, which we will do next week. I think I will communicate the certain time of our next session later in announcement. So, yeah, and this is it. Thank you very much, guys, for your attention, for your participation, and yeah, I wish you a great day, and see you next week. Bye. Thank you.